Okay, hello everyone. So today we are going to talk about the Lab7 inductors and capacitor. Okay, so first of all, uh, I want to talk about like how physically looks like for inductor and capacitor. So for a capacitor, it's basically just two metal plate. Okay, and if you put them close together, they like work as a capacitor and make sure they are not touching each other. They have some distance in between. Okay, and here is the equation for the capacitance. And the inductor is just a like a coil. Okay, it's many tens of coil. Okay, and here is the inductance equation. Helpfully, you already use it in the pre-lab. Okay, and before you start this lab, I think you should already read through the manual and especially this example. Okay, so and if you done the pre-lab, this question, I think you should already familiar with this example. Okay, so let's talk about this lab. Okay, so there are three tasks. The first two are similar. You're going to measure the capacitance and the inductance. And the third task, you're going to build a voltage division circuit by using the capacitor. Okay, so task 1, task 2, you're going to build the circuit given in here. Okay, it will be something looks like this. Okay, and so you say you have you will build a, you will use a resistor, resistance in series with a capacitor or inductor. Okay, so DUT is device under test. For task 1, you're going to use a capacitor. For task 2, you're going to use an inductor. And you will use W1 from your AD2 to generate an AC source or AC signal and connect to RSense and DOT. And you are going to use both channel to measure the voltage across the RSense and the capacitor or inductor. So the difference with what you did before is you're going to use, for example, you use channel 1 to measure resistance. You want to put 1 plus and 1 minus on two sides of the resistor. Okay, remember the 1 minus should be here. And then you use channel 2 to measure the voltage across the capacitor or inductor. So 2 plus at here and 2 minus at here. And remember, you should have a ground here. Okay, so that's how you build the circuit. And then after you build the circuit, you should see something like this on your scope. Okay, so you have one sine wave and another sine wave with 19 degrees shift. Okay, so then you know you can define this one as sine wave, then this one will be cosine wave. Or you can define this one as sine wave, then this one will be cosine wave. They just have 19 degrees phase shift. Okay, so after you get these two plot, okay, so you can use these two equations to calculate the capacitance or inductance. So first step, what you are going to do is you want to find the equation for V dot or I dot. So voltage cross capacitor and or inductor or and current cross capacitor or inductor. So remember, the voltage and current will be a sine wave function, right? So because it's a sine wave, so you will have a sine wave function. So it's similar with what you did in pre-lab and in this example. And remember how you can get the current, okay, is equal to the voltage cross this resistor divided by resistance. So that will be the current cross this capacitor or inductor. Okay, so after you set the equation, you can do the calculation. Okay, so you need to do the derivative of the voltage in this task, the first task, or derivative of the current in second task. And it will be easier if you choose put the sine wave for voltage or sine wave for current in task 2. So the reason is that because when you derive the sine wave, it will be just something multiply cosine, okay? But if you do the derivative of cosine, it will be minus something. Okay, so it will be easier. You choose sine to do the derivative. Okay, so after you do the derivative, it will be simply two function at two sides of the equation, okay? Cosine wave something or sine wave something, and then you can do the consolidation. Then it will left some number. So as shown in this example, the cosine or sine will be cancel each other. Then you will have some numbers. And after that, you will able to find the capacitance or inductance. Okay, so that's how you do the task 1 and the task 2. Okay, so and in task 1, step number 5 and step number 6, you're going to do the same thing, but change the 10 nanofarad capacitor to with two parallel capacitor, and in step 6 you will use 2 capacitor in series. First of all, what's the 10 nanofarad capacitor? The code for this is you need to check the document I sent out earlier about the resistor code and the resistor color code and the capacitor code, or you can just Google 10 nanofarad capacitor code. Okay, if I remember correctly, the number for 10 nanofarad capacitor should be 103. Okay, then you do step 5 and step 6, parallel and in series. So if you get everything correctly, you should have something like this. So when the two capacitor in parallel, the total capacitance is C1 plus C2, okay? And when two capacitor in series, the total capacitance is equal to this equation. Okay, so the way you calculate this is inverse with the way you calculate the resistance. Okay. And when we usually when we deal with a capacitor and the inductor, we introduce something called impedance. Okay. And remember, when we have capacitor and inductor, usually we deal with AC signal. Okay, the reason is that if we have DC signal, the capacitor will be like an open circuit, right? Because if you remember, capacitor is just two plate, not two metal plate, they not touch each other. So if you have only DC signal, the current cannot go through this. So it will be like an open signal. I mean, open circuit. Similar with inductor, if you only have a DC signal, the current will just go through. So it will be like a short circuit. Okay. So when we talk about impedance, we use letter Z to represent it. And the impedance is kind of like a resistance. Okay, so for example, the impedance of a resistor is just equal to resistance. And the impedance of a capacitor is equal to this equation. Okay, so 1 over J omega C. J is the imaginary number. And for the inductor, the impedance is equal to J omega L. And the omega in here is equal to 2 pi F. And the F is the frequency. Okay, you see the impedance about capacitor and the inductor is related to the frequency cross the component. Okay, so that's task 1 and task 2. Before I move to task 3, there are some number you want to know. So 10 to the minus 6, that's macro. 10 to the minus 9, that's nano. Okay, so remember those number are important when you do the calculation. All right, so that's task 2. So then task 3, you're going to build this circuit. And remember, so if you check here, the schematic in here, there is a RS, but and also similar here, you have RS. But since you are using AD2, you don't worry about RS. Okay, just ignore the RS in here and ignore the RS in here, because the RS is the internal resistance of the function generator in the benchtop equipment. But since you're using AD2, there is no internal RS. So just ignore about it. Okay. So then you're going to build this circuit in task 3. Okay, the circuit will be something like this. Okay, so you use maybe you want to use channel 1 to detect the input. So the 1 plus will be connect to the top of the capacitor, and here is connect to W1. Okay, you want to use W1 to generate an AC signal in first few steps. And then you want to use, maybe you want to use channel 2 to detect the output. Okay, you want to put 2 plus in between of the capacitor. And then 1 minus and 2 minus should connect to here, and here should be connected to ground. Okay, so that's how you build a circuit. Okay, and then you follow the steps, and don't forget to take a screenshot. And the step number 6, you want to sweep the frequency from 1 Hertz to 1 kHz, and to see how does the attenuation ratio change. So first of all, the attenuation ratio is output over input. Okay, so that's the attenuation ratio. And when you sweep from 1 Hertz to 1 kHz, so remember 1 Hertz is kind of very low, slow signal. So remember, when you have slow signal, if you're unable to detect it in the normal mode, you're going to use row mode. Okay, so you can use row mode when you have very slow signal. Okay, so that's step 6. And step 7, you just change the function generator to DC mode and sweep the voltage to see is the circuit still work as a voltage divider. Okay, I think that's it for today. And remember, if you haven't submitted the pre-lab, please do it as soon as possible. And also the lab practical should be, you should already submit the lab practical. Okay, that's it for today. And let me know if you have any questions.